Thank you very much, dear Marcos, for your great presentation. And in the meanwhile, we already collected questions from our audience. And our colleague Abraham is sharing on the screen. Shall we go one by one? The first one is from Ms. Thủy Nguyễn or Thủy Nguyễn. Why do the micropollutants raise a problem that needed to be addressed when concerning all pollutants to remove?
Well, thank you for the question. That's a good question you posed. What I mentioned is that we're being pressed by the reality. Now we are discovering problems that we were not able to discover before, because in the laboratory, the analytical equipment are now, we only were concerned about milligrams per liter, then micrograms per liter, nanograms per liter, and then many developed countries or high-income countries, they are addressing pollutants. But it's not a consensus. Even in their case, they are now concerned about pollutants. We are not sure what's the best treatment process, how to remove these micropollutants, endocrine disruptors, personal hygiene care, antibiotics, and so on and so on. So this is a huge list of problems that we received, low and middle income countries, and how to solve this. I think we need to be concerned about them, but they should not be our priority. If we are not removing, well, organic matter, if we are not removing, if required, pathogenic organisms, or if required nitrogen and phosphorus, I think this should be one of the steps we should face later on, but we cannot mix everything together.
Thank you. Let us move to the next one from Caleb Osei Apau. The question concerns the system of wastewater stabilization points and the constructed wetlands. It observed that these systems are not very good, have low nutrient removal efficiency. Does it mean that these methods are not favorable for nutrient removal? If yes, then what method can be suggested for efficient nutrient removal?
Okay, Caleb, thank you for your question. It seems to be a bit disappointing when we say, well, okay, either ponds or wetlands, they don't perform well in terms of reaching high removal efficiencies for nitrogen and phosphorus. I think it's even more disappointing when we think in terms of wetlands, constructed wetlands, because we have the expectation that, okay, we have plants, and the plants, they will absorb nitrogen and phosphorus in order to produce their biomass, the plant biomass. Okay, they do this, but the applied load, we apply a certain load of nitrogen, a certain load of phosphorus per square meter, for instance, grams per square meter per day. The applied loads are much higher than the uptake that the plants can achieve. So typically they would achieve, I would say, 7% of the nitrogen and phosphorus could be removed by plant uptake, okay? 5, 6, 7, 8, 10%. Okay, we could reach very high removal efficiencies if we adopted very large areas, very, very large areas. In other words, more plants. Then we would balance what has been provided, so the input load and the output from the uptake. But this is not practical because this would take huge areas. And in terms of stabilization ponds, the only one I think it has been shown to perform well is maturation ponds, shallow maturation ponds. Many simultaneous mechanisms working together. We could think that's algal removal, algae removing nitrogen and phosphorus. It also happens, but the discussion is similar to the discussion we had with the plants, okay? So what method can be suggested for efficient nutrient removal? I think those I showed to you in the photographs, if we need to achieve high ammonia removal or high total nitrogen removal, high total phosphorus removal, we showed you some of the possibilities, but then not necessarily incorporating only natural treatment processes, okay?
Yes, thank you very much. Let's move to the next one from Arnold Esimwe. he asked about, do we have international design parameters for sewage treatment plants?
Well, yes, we do, and it depends on the treatment process. So each of the major treatment processes, they have, well, they have national standards or guidelines or norms. In some countries, they have even each state has their own guidelines or norms. In terms of international standards, we have, it's difficult to have international standards. If you think in terms of European community, you could have one legislation. But we have, in most of the cases, guidelines, because each country would accept or not. But I emphasize that I think when we are designing something, we should not use only the national standards, if they are available. We should use the most recent available literature, so the publications, because things change relatively quickly, new processes appear or processes are improved. So what I like to do is I design according to the best available literature, and then I check with the standards. If I need something here in terms of Brazil, I check with the standards, okay? But then coming as final comment to your question, yes, for instance, in Germany, they have the German standards, many German standards for different treatment process. You just follow these standards, and many countries have something similar to that.
Yeah, great. Let us move to the next question. And in the meantime, I would ask Abraham to share the screen of questions again. The next one is about the, do we have standards for effluents? Could you share some standards for
developing countries?
Yeah, effluents for developing countries.
Okay. Oh, this is such a polemical issue. As I was telling, many countries, they just copy the international standards, or I would say standards from some countries. And when it comes to their own countries, they are not applicable anymore. They just remain in the legislation as a written piece, but not achieved in practice. So it is very frustrating to think, I will use the most advanced standards, discharge standards, so effluent quality required, because I want to improve the environment. Okay, that's a good pathway, but we should not put unachievable, unaffordable requirements, because otherwise they would not be complied with, and this would be generate a frustration and a discredit towards achieving the standards. So for developing countries, I think in one of my books, I make a suggestion here of discharge standards in terms of BOD. I think they should be lower than those, of course, adopted by the European community. BOD or COD, I think nitrogen and phosphorus should be used only if you are discharging in sensitive water bodies, subject, for instance, to eutrophication. Because if we specify nitrogen and phosphorus removal as a requirement for all treatment plants, we will not be able to comply with this. Pathogen removal, it can be discussed, it could be adopted, but anyway, it will also be difficult, because for us to achieve good pathogen removal, in most of the cases, we need to have a very good suspended solids removal and organic matter removal. So we need to improve the efficiency or achieve high removal efficiencies in terms of organic matter and suspended solids in order to adopt disinfection. But as I told you, we cannot use maturation ponds. But this is a good question. It's subject to so much controversy in the countries. In Brazil here, in my state, we are discussing an updating of our discharge standards. And you can imagine there are pressures from various sides, and you have to come to a negotiating table, and there is no straight answer, final answer to this very important question.
Thank you. Next question is from Samir, who is facing problem with uncontrolled foaming at STPs in the UASB reactors. What are the causes and possible control measures for that problem?
Okay, Samir, UASB reactors. So we could think in terms of scum formation. So the scum, which is bacterial growth, together with some fats and grease, which float, and they tend to cover the upper part of UASB reactors. So we could call foaming, but we could think in terms of foaming also related to a detergent, tensioactive agents. Okay, so let's discuss the two of them. So if you're thinking in terms of detergent removal, anaerobic processes are not efficient for that. You need an aerobic stage in order to achieve foam removal, detergent, tensioactive agents. Okay, if we are discussing about scum, and that's a major problem because the scum can build up inside the USB reactor, which is a closed reactor. Sometimes it can even destroy the tri-phase separator, the gas, liquid, solid phase separator. I have a colleague, Carlos Chanicharo. You saw his name in one of the books. He's one of our experts in anaerobic treatment. He's studying a lot how to do automatic removal of the scum, because it's not simple to remove the scum just by a hose. Open a gate, the scum will not move towards the gate or the valve. Just go with a hose. If you have a large reactor, it won't be feasible. So how to do this removal on a hydraulic basis? It would be difficult to explain here, but there are some possibilities, yes. Okay.
Yes, thank you very much. The next question is from Abdul Rashid from Afghanistan. In the context of a low-income country, what kind of wastewater treatment process is good for Afghanistan?
Well, Abdul, I think the best answer would be we need to do, in all cases, a good study of the local conditions, because even for Afghanistan as a whole, I don't think we should make a generalization. If you're thinking in terms of large cities or small communities, if you have land available, if you do not have land available, so if you need to achieve a high removal efficiency because you are discharging in some places, or if you don't need such a high removal efficiency. So I think all the discussion we had here in all the treatment processes here could be used for Afghanistan. Of course, you have to check about climatic conditions, because some of them are very influenced, especially the natural treatment process, are very dependent on climatic conditions, ponds very much, and also wetlands. And before we move to the next question, I forgot to mention about another thing we have to think, the next generation, I would say, is resource recovery. In my presentation, I'm only talking about removing. But in many cases, we should not think of everything as pollutants. They are resources that can be removed. But this is another discussion, but I think we should prepare to this change of view. Okay.
Yeah, thank you very much. Let us move on to the next one of Rabea Khatoon. Is there any suggestion for sewage treatment in a crisis-affected high-density area? In this case, the Rohingya camps in Bangladesh.
Okay, Rabea, your question is very good. And I can say that IHE Delft is working and has worked a lot with this. So they have a group of people, Professor Damir is working a lot about emergency situations, crisis, refugee camps, and provisional people living under many conditions. We have to think initially in terms of the wastewater, how it will be collected. So we will use toilets. So to use good toilets to give them to the people dignity when they go to the toilet. So the first interface is very important, to have good toilets and people to use. I don't think in an emergency situation that will be used only for some months, that biological treatment processes would be a good solution, because biological treatment process, they take sometimes some months in order for the bacteria to grow, for the biomass to grow. And then in most cases, you could use a physical or physical-chemical treatment because it's fast. You add some product and then you get the removal. But I think, and then you produce sludge. What to do with the sludge? But anyway, I refer you back to the superb productions that IHE has done in terms of this emergency situation camps.
Thank you. The next one is from Alex Campbell. The question is, the professor mentioned management of treatment plants as a major issue. It is great to discuss the technology, but then separating management from a technology discussion is perhaps part of the issue with sustainability of all types of treatment plants around the world. Could you comment on that?
Yes, Alex, that's a very important point. So in my presentation, I was able to cover only technologies. Okay, for each technology, when I discussed about applicability, in a certain way, I was discussing about management, but we cannot separate both. And the point I made at the very beginning is that sometimes we engineers, for instance, I'm an engineer, and then many engineers think, okay, I have the best solution, I will use the solution, I will provide this, and we do not take into account the wishes of the populations, especially in small communities, if you're applying a solution for small communities. Who will operate the treatment plant? Is it well guaranteed? Because I can put a very good treatment process, activated sludge, superb. Are we able to operate it? Do we have enough energy? And so on. Because if you apply a treatment process that is not able to achieve the performance on the long run, it is not sustainable. Even some treatment process that today, I said, well, they are natural treatment process. We could think, okay, they are sustainable treatment process. Wetlands, people tend to say, wetlands are sustainable treatment process because we involve plants. But if they are not designed and controlled well, for instance, if they clog very quickly and then this wastewater starts to run on the surface, they are not sustainable anymore because they lost one of their main characteristics. So that's why we have to think a lot in terms of sustainability, in terms of operation, capacity building of the operational staff, and doing also good designs that give flexibility for the operation. That's essential. Otherwise, we will not be able to tackle this.
Thank you, Marcos. I move to the next one from Andere Mihiruka. The question concerns the sustainability. How best can we ensure sustainability of wastewater treatment plants in developing countries, given that most of these plants work well in the initial stage, followed by slow but then systematic collapse?
Again, I think, Andere, the discussion is similar to the one we have just had. So I think we need to invest well in operation, not only in capacity building of the operational staff, but also if we have mechanical equipment in our treatment plant, we need to have spare parts. We need to give a preventive maintenance on all the equipment, because otherwise, simple things like if a pump breaks, okay, I have a second pump, a spare pump, but if the second spare pump breaks again, okay, you have a collapse in your treatment plant. So we need a good structure, because all the treatment processes I showed to you and we discussed it are able to give the performance according to their applicability range. Okay, ponds, they cannot give a very high performance because they release algae in the effluent, okay? So the removal efficiency decreases. But in all of them, we are able to keep with the expected range, but we need to do things well. As I said, if a wetland is completely clogged, okay, it will not operate well. It's a robust treatment process. You can still keep the removal efficiency, but you can have problems with mosquitoes, bad smell, if you're having surface flow in your treatment wetland. So invest in preventive maintenance, capacity building, spare parts, and so on.
Thank you very much, Marcos. So far, it has been very nice, the interaction between you. I have just a practical question. Is it okay to go on for another 10 minutes to address the questions?
For me, it's a pleasure. I'm available.
Great. Yeah. Let us continue then. It's great. The next question is from Remy. Usually in developing countries, we don't have a sewage network, but rather have a cesspool emptier lorries that collect wastewater and dump it in the treatment plants. Therefore, the system don't have a continuous inflow of wastewater. So in that case, which system do you recommend?
Yes, you're right. So in many countries, in many cities, small cities, middle-sized cities, and even large cities, we have on-site solutions involving, for instance, cesspool or septic tanks, and so on. In this case, for instance, if we're thinking in terms of septic tanks, we have a small removal from the liquid fraction, but then we build up sludge. And I think we're referring mainly to the sludge that is produced in this type of solution. So it needs to be collected, transported, as you said, by lorries, and it needs to be treated. In many cases, you do not have a sewage treatment plant in which you can discharge your sludge. If you do have, okay, it's always good to have a receiving tank. You receive the septic tank sludge, and then you discharge. You are able to discharge this not on a trunk-by-trunk basis. You can pump it to your treatment plant, for instance, on a continuous basis. The lorries are arriving on an intermittent basis, but you store this in a receiving tank, and then you pump into your treatment plant in order to decrease the loads, okay? But of course, you need to analyze well the treatment process you have, because you cannot overload your treatment plant, because otherwise your treatment plant will be overloaded, and as we were discussing, the removal efficiency will go down, you have bad smells. And also natural treatment processes are a possibility here, especially because they are very large reactors, so they have a very good buffer capacity to receive the individual loads. So it's common in many cases for these septic tank sludge to be discharged in systems with stabilization ponds, okay? And also I should mention that we have constructed wetlands, especially dedicated to sludge. They are very good, very important. I saw that Lindia Strande is one of the participants here. You should check the book she has written with Damir and Maritza. It's on the management of sludge from septic tanks. It's a superb book. There you will find very good indications how to do it. So thanks, Linda, for being around in the participant list here.
Thank you, Marcos. Let us move on the next question with Vilia Ando Yonko. The question is, how do we maintain efficiencies at plants' uptake of nutrients? What will happen to effluent quality when the plants decay? Doesn't it produce lignin and releases back into the nutrients?
Okay, you are right. So if we're talking about wetlands, constructed wetlands, we need to do a management with our plants, because they grow and they need to be cut from time to time. How frequently? It depends on the plant species you are using. Sometimes you have to cut, you don't cut the whole plant. It's not a pruning, it's really a cutting. You cut it from the stem, you leave, for instance, 20 centimeters of stem above the surface of the wetland. If you are aiming at increasing your nutrient removal, you should cut, you should not wait for the plant to grow and start what we call the senescence, when they reach the highest height, and then they start to decay. If you cut more frequently when the plants are in their growing stage, at this time is when they uptake the highest rate of nutrients. So if you're able to cut more frequently and keeps the plants always in the growing stage, you will be able to upgrade your removal efficiency. But still, it will not be high unless you have very, very large wetlands, as we discussed. In other words, you apply very low loading rates. And you're right, if you just cut the plants and you allow the plants to remain there, they will release. Whatever they have uptaken, they will release. So you need to cut the plants and take out from the wetlands. It is very good if you can use them on a productive basis, either under controlled conditions for composting and given to cattle, or for using for other purposes. That would be the best possibility.
Thank you. The next two questions, which I would love to combine, is relating to temperature. The first one is from Mona. She asked, which strategy do you suggest for cold water? And the other one is from Pamela Serron. She says, now consider the fluctuation in the temperature that occurs in warm climate regions. Do you share any insight on the effect of temperature on removal efficiency on natural systems?
Thanks, yes, very important. So if we have consistently low temperatures, I think the natural treatment process will suffer from this. Because, okay, in some cases they can be applied. I told you that there are 3,000 stabilization ponds in France, 8,000 in the United States, but it's not the best possibility for them. Okay, they can be adopted, but they will use much larger areas for treating the same flow or the same load if you had warmer temperatures, okay? For instance, in France, the stabilization ponds, the facultative ponds there, they use, I would say, 3 to 4 times the area we could use here in my region. It makes a lot of difference. And then if you have consistently cold water, you could apply treatment processes that depend less on climatic conditions. Typically, the more compact systems, the anaerobic reactors I told you are not a good suggestion. They depend on good climatic conditions. So that's why they are being widely adopted here in Brazil. But you still have activated sludge. You can have even more sophisticated things like membrane bioreactors and so on, okay? And then the comment from Pamela was, okay, but if your temperature fluctuates, usually we design a natural treatment process based on the more adverse temperature conditions. For instance, what is the mean temperature in the coldest month? And then we take this temperature and then we design we specify the loading rates that should be applied. In other words, we calculate the required area or volume, meaning that they should work well during the winter months. In the summer months, it is expected that they should perform even better. But you have very wide temperature variations, and if your winter is long and very cold temperatures, I think the comments I made to the question of Mona should apply. You should, okay, I will use more compact or intensive systems that depend less on climatic conditions. I have aeration. I can control my aeration. I have recirculation. I can control my recirculation, the wastage of sludge, and so on.
Thank you, Marcos. And the next question is from a colleague from company GTEC IGIP. Question is how to set up a tariff structure to cover cost for sewage treatment with a small community which cannot be afforded by inhabitants.
Well, thanks for the question. And very important, I think this is one of the management questions we were discussing. Many small populations, okay, the whole sanitation infrastructure is not cheap. It's relatively expensive, and people could not afford. I think the solution is to have things on a, how do you call it in English? Anyway, we call here as a cross-subsidy. So the provider of the sanitation service operates one city which is larger, and it can have profits in this larger city. And the profits are used to cover the deficit in small populations. Otherwise, it will be a problem. So this is something that is being very much discussed here in Brazil, because in Brazil, 2 years ago, we opened the way to privatization of the water treatment, of water supply and wastewater collection and treatment. Okay, it's fair. Any private service provider can do a very good job. But if you open to the private sector only the best cities, the ones in which they will have profit, what about the small cities if they are left over? So you need to put everything together. If someone is going to operate a profitable city, this company should also operate the non-profitable cities. Otherwise, you cannot pass this on to the tariff scheme because the population will not be able to afford it.
Great. Let us move down, Abraham. Thank you. We have the next question from Shalongo Angula. What are the possible and practical resource recovery interventions that can be introduced in sewage treatment? Or is resource recovery still far-fetched in low and middle income countries?
Well, Shalongo, that's also an important question and almost a comment you made. I think resource recovery is very important, and the resource recovery possibilities are very much dependent on the treatment process you will apply. If you're applying activated sludge, you can recover phosphorus, for instance, from the sludge treatment line. It's a small flow. You can make a precipitation of phosphorus, recovering as struvite, for instance, and then use the phosphorus. Sludge. Sludge is one possibility. Now for different treatment process, you need to treat well sludge and what to do with the sludge. You can, if you have a thermal treatment, then you can even use, if you have an anaerobic reactor, the biogas from the anaerobic reactor or anaerobic stage for sludge treatment can be used for thermal treatment of the sludge. And sludge can be used as soil conditioner. But an important question you made, and I tend to agree with you, that the resource recovery cannot be more complex than the treatment process itself. If we are talking about saying that, okay, we have management issues, sometimes the operation or the maintenance is not adequate. And if we have a failure in our treatment process because we are not operating well, what if we put a resource recovery, which is even more complex and it's not well maintained and operated? It will generate the same type of frustration. So things need to be very well thought. So there are several possibilities for resource recovery. Some of them are not simple. If we are thinking in terms of simple things, for instance, just using the effluent produced from a treatment plant for irrigation purposes, it's a superb possibility. So especially if you incorporate maturation ponds, and then the effluent has, as we discussed, very low pathogen concentrations. It can be used for irrigation, either restricted irrigation or unrestricted irrigation. This is one possibility. But again, management issues, because this wastewater needs to be transported in the site in which it will be applied for irrigation. We have guidelines from the World Health Organization for this type of use, water use, wastewater use, and several countries have their own specific standards for that. United States, or even some states, California has their own standards. Israel uses a lot. Most of the wastewater produced is used on the agriculture, which is very, very important for the Israeli practice. Okay?
Yes, I noticed that we are going over time, but I see that people really appreciate your wisdom, Marcos. So let us take the last two questions. Okay. The next one is from Kumudini. Selection of technology should take into account the capacities on operation and maintenance of the systems. He would appreciate it if you could share opinions on the aspect of the technology presented.
Yes, I entirely agree with you. And I think the technologies I presented, they are less intensive in terms of operational requirements. I could make a generalization that the natural, extensive treatment process, they required very simple operation. As a matter of fact, they required more maintenance than operation. Maintenance of the preliminary treatment, of the pumps, cutting the plants as we discussed it. But this is simple. This can be done without much complexity, and this can be sustainable on the long run. If we apply more sophisticated treatment processes, they are excellent. Activated sludge is excellent, but you cannot apply an activated sludge treatment plant if you're not sure about exactly what we wrote. I'm looking here at the screen, capacity on operation and maintenance of the system. Otherwise, there will be a lot of frustration. 1 year after you started up your treatment plant, performance will decrease and decrease, eventually collapse, and it will be left without operation. Then we need to guarantee, and I think each treatment process has its own requirements. But as a generalization, the natural treatment processes are much simpler to operate, but they require much more area. Well, each case is site-specific.
Thank you. Let us go to the last question by Arnold. How can climate change be integrated in improvement of sewage treatment plants to improve efficiency, especially in low-income communities?
Good point, Arnold. Yes, I do think we need to incorporate this in the design. Some design criteria are based on temperatures, okay? And then we have to be able to forecast more or less what will be the temperature in the next years. I think this is still complex. We could incorporate some safety in our designs, but we have to be careful when incorporating safety, because we cannot incorporate safety in one aspect here, climatic conditions. Also, we need to do population forecast. What will be the population after 20 or 30 years of operation? Because my treatment plant needs to be designed for a future population. And then we can incorporate a safety here, a safety there. And so if we start incorporating safety in so many aspects, we start to increase and increase and increase our treatment plant, and then the costs will be larger. So it depends very much on the experience, on the common sense of the designer, together with the people who will operate. And also flexibility should be incorporated, because at the operating stage, it's always good when the operator is able to change something, to implement one recirculation, to change the applied load, to divert to another unit. So flexibility will help if we have the problems you mentioned, but it is something more difficult to implement for sure. But you're entirely right. There is a lot of discussion on global warming and the impacts in terms of water supply, water availability, water scarcity, and also in terms of not only on treatment, also in terms of the receiving water body. What in terms of the receiving water body, in terms of the dilution of the self-purification capacity of the receiving river or lake.
Thank you very much, Marcos. I think with that, we would happily conclude the Q&A session. On behalf also of all the participants, we would like to thank you very much for your highly informative and inspiring talk. As much as all of the participants, we really appreciate your energy, enthusiasm, but also the wisdom of the talk and also the Q&A session today. We'd like to wish you a lot of health, enjoy in continuing your great work. I would also like to thank our participants very much for your kind attention and interactions. We will keep you all posted about the upcoming webinars, podcasts, and blog articles within this initiative between ISE Delft and the Water Channel. For all the details, please access the webpage on www.thewaterchannel.com. www.ise. We do hope to keep in touch with you and wishing you all the best. And with this, I would like to close today's webinar session. Thank you very much.
Thank you very much. All the best for all of you. It has really been a pleasure. So I'm really, really very happy, and I wish you all the success.